Every chip powering an American jet, medical device, or data center depends on critical materials and chemistries we don't control. SandboxAQ will fix this. With a new $500 million CHIPS R&D award, our scientists will use our large quantitative models to develop US-based alternatives for PFAS-free process chemicals, catalysts, rare earth-free magnets, and battery systems. Here's a look at the team and science powering the work.
My name is Shalini Sharma. I am the head of Semiconductor Materials Innovation and Cross-Vertical Strategy at SandboxAQ.
My name is Anshal, and I lead AI for material science at SandboxAQ.
My name is Ayush Singh. I lead the Catalyst Discovery team at SandboxAQ.
As the AI revolution accelerates, semiconductors have become the most critical hardware. They are foundational to our defense systems, our communications, and our critical infrastructure. That is exactly where SandboxAQ can help by using advanced simulations and AI to explore and accelerate materials innovation more efficiently than slow traditional approaches.
Traditionally, discovering a new material can take many years. We use physics-based AI to dramatically accelerate that process and quickly identify the most promising candidates.
Because these models are grounded in physics, we can predict how materials will behave before they're ever made.
We then work closely with US companies to validate those materials and bring them to the market. Our team has decades of experience in science and technologies. For example, I have worked in the battery industry for 22 years. We bring together world-class scientists and engineers to develop solutions for real-world problems.
Our team has published tens of papers and patents in the areas of catalysts, batteries, PFAS, and many others. For example, our AQCat25 model, recently published in Nature NPJ Computational Materials, captures critical magnetic effects that are crucial for accurately simulating catalysts at industrial scale. We regularly partner with Fortune 500 companies and national labs to deploy our large quantitative models for materials discovery.
SandboxAQ is uniquely positioned to accelerate scientific discovery. The large quantitative models that Sandbox has developed uses quantitative data grounded in equations of physics, chemistry, and mathematics to simulate complex real-world systems with very high precision. LQMs will radically revolutionize the way we drive innovation.
Together, we can help strengthen Americans' leadership in critical materials and advanced manufacturing.